This presentation will kind of be a second half to the first presentation. And this one focuses more on outbound traffic versus exposing services. So this one's entitled Secure Internet Control in Google Cloud. Again, David was not able to be here. He was hurt and he was going to be helping on these presentations, but you guys will have to save that treat until next year. So let's focus on the problem. What is the problem today? Companies are moving to the cloud, and they're taking all of their current security standards that they want, that they're used to in data centers and on-prem, and they're trying to move those security measures to the cloud. They try to do this by doing a lift and shift of current architectures. So we've seen these architectures in data centers and in large enterprises where there's a DMZ and a series of firewalls with a LAN segment. There might be some sort of hardware WAF appliance as well. So when you try to take these features and you move them to cloud wasn't built for that. That solution, you can build it, but it becomes clunky. It becomes complex. They're not a cloud native solution. They're also costly, buying additional licenses, paying for compute and having to manage them, as well as they're not scalable. So if you ever try to deploy a hardware appliance in cloud, generally you have to have multiple appliances per region, or you have to have multiple appliances per region and then add a second region with multiple appliances there. And then you become, it becomes an issue with load balancing in between the two and state. So a couple of these we were talking about here. You can see the first graphic here is just simplistic in that on-prem architecture has a DMZ and a LAN, and they separate with a firewall. That's the simplistic nature of an on-prem architecture with clearly defined or demarcated zones. Also, when you try to take that architecture and move it to the cloud, you generally end up with something like the second graphic here. And if the second graphic looks complex, it is. So when you try to deploy a load balancer, you have to have a select load balancer because sometimes the firewall wants to see source IP address traffic. So you got to use a network load balancer, which is a regional resource. And then you're again deploying two appliances because you want HA. And then you've got to do some serious natting to get the traffic to go through the appliance and then map that to the back end, which still has yet another load balancer or proxy. And outbound traffic is just as complex. You would have to have an internal load balancer in between the two appliances, and then still yet do another NAT to get out to the internet. So this becomes complex, and then if something goes wrong, it's very difficult to troubleshoot and track down where the problem is with this type of complex architecture. And then we said also that when you try to do multi-region deployments, like the bottom graphic here, you get into state issues. So if traffic wanted to go to one region or another, how does the load balancer know which one's healthy and what current transactions or sockets are open, and how would they transfer that state if you're in midst of a transaction? So, but like we said, correct load balancer. And if you want to, generally when you do a hardware appliance in the cloud, it limits you to only a network load balancer in Google Cloud if you want it to work correctly. And then, like we said, on the firewall itself, the only way we've seen this be successful is to really just break out a spreadsheet and write down ports, and you NAT traffic to high ports. So application 1 or service 1 goes to port 3333, application 2 goes to 33334, right? So, and you're literally keeping a manual record of traffic transactions in order to map and think about this at scale. say 100 applications, each application has 4 or 5 services that's supported underneath. It's almost impossible. Although the security folks are happy because you kept their firewall. As well, you're going through one load balancer on the external side, you're going through a second NAT to the firewall, and you're going through a third load balancer internally, say with like a GKE gateway or an ingress controller. So the latency increases as well. So how can we address this solution? We can combine 2 Google Cloud managed services and come up with a solution that addresses this. And we'll jump into that now. So Cloud NGFW is a Google Cloud managed service. It's a distributed firewall, and it's also a hierarchical firewall. What does that exactly mean? So distributed firewall, I'm defining it in one place, and it distributes out and actually applies to individual NICs of VMs or nodes. So distributed, that there's no actual appliance, but it lives in software and gets applied to each NIC in the VPC. Hierarchical, meaning I can apply different policies at different levels in my organization and have them inherited or not inherited at certain levels. So I can apply it to certain teams, apply different policies to yet other teams. This firewall is highly available and can operate at global scale, which is what we're used to with Google. It's capable of advanced threat detection. So things that it can block, if you're familiar with Tor exit nodes. So Tor is it's an acronym. It stands for the onion router. And that's basically an overlay network that runs on your computer. You've probably heard of the dark web before. This is the dark web. So it's an overlay network that runs on top of the internet. And what happens here is attackers can jump into this overlay network, the Tor network, and jump out at different countries. So I can leave the Tor network, say in, I don't know, we'll just make up a country, right? Turkey, London, or England. And right, and I can jump out, and it makes the traffic seem like it's coming from that country, while disguising the original source, right, of the traffic in the Tor network. So these exit nodes are dangerous, and so and they're hard to track because they're constantly changing. So Google Cloud Next Gen Firewall is getting a constant feed from Palo Alto underneath of what these IP addresses are, and they're able to make dynamic changes to the firewall policies on your behalf through these feeds. It can also block VPN IPs. So another way to disguise traffic is jumping into a VPN network or a proxy network, which is also disguising the source IP address of the traffic. These type of VPN networks that you can purchase access to disguise yourself on the internet have known exit nodes as well. So again, this is received from Palo Alto and is a feed, and Google's dynamically updating these firewall rules to these VPN exit nodes as well. There's proxy IPs, there's known malicious IPs that are used for DDoS, stuff like that, as well as any of the crypto mining IPs, in which what's happening there is you're getting hacked. They're using your compute resources for mining, and without paying for it, right? So it can block those known IP addresses those attacks come from, as well as it can use DNS names. So I can just say, you would not do this, but block google.com, right? I don't have to know the IP addresses. You wouldn't block Google, but just as an example, right? So, and another one is you can just put in a country code. So I can say, just for instance, right now, North Korea is kind of on the hot seat, right? So I could say block North Korea, and any IP address that's coming out of North Korea, it would automatically block. And I don't have to keep up with the IP addresses. If they change them, it updates. Not to pick on North Korea, but I mean, just say if we wanted to block traffic from a specific country, right? This NGFW is also capable of deep packet inspection. So therefore it needs to encrypt, decrypt TLS, and it's capable of doing that. The second part of our solution is a secure web proxy, which is another Google managed service. It's an auto scaling, as it says here, and it's a secure proxy, right? That Google hosts. And so how does that work? Traffic that's leaving the cloud, headed out to the internet, or leaving the cloud, heading to on-prem. It hits this proxy, and a proxy in its most basic form is terminating the traffic and starting a new stream. So if I'm A wants to talk to C, it gets stopped by B, B starts a new connection to C. So you never really see, A never really sees C. They're always talking to B, the intermediary. That's the proxy. So Google hosts this proxy, and it allows you to do a whitelist, blacklist approach. So I can go to certain internet websites and just say, block everything, and let people go to Google, or let people go to update.com, or right to do updates of services. And then I can block everything else, or I can do like a blacklist approach would be the converse of that, right? And it also has advanced observability. So I can see what services are trying to connect to what endpoints on the internet, which is also important for security compliance. It is also capable of encryption or decryption. So we can take that TLS, break it, and look at what my services are really trying to go to if it's encrypted. And so if you're going to on-prem, it can be used alone because it would stay RFC 1918 address compliant. And if you're going to the internet, it can be used in combination with Cloud NAT, Network Address Translation Service, so that it can receive a public IP on the way out, and you can still use the secure web proxy. So if we combine these two things, the NGFW with the secure web proxy, we come up with a solution. And so you're getting the inbound and outbound filtering, right, for the Tor nodes and the malicious exit points, stuff like that, as well as blocking countries. But you're also getting the visibility of the secure web proxy, and you're getting the whitelist blacklist approach. So I can really hone in on where my traffic is going and secure it against malware. That's pretty important. So combining these can provide, a unique solution. So let's jump in a little further what that looks like. So if you can see in the diagram here, we have workloads down here in the bottom. And the first use case is workloads trying to go talk to something maybe in a remote point, like a store or brick and mortar, something like that, or even a data center, corporate office. And so how that looks, we've got the distributed firewall. So it's sitting on the NIC of the VM. So we're checking against malware before it heads to on-prem. And then we're using the secure web proxy to say, not only that, you're allowed to go to, on-prem, but you can only go to, SUS or something like that, like a Windows Update server that's on-prem, versus hitting maybe an intranet site that we might not need for a service, right? So our next use case that it addresses is the one in the middle with the purple line here, and that's your services on Google Cloud, and they're trying to go out to the internet for X, Y, or Z updates, talking to a third-party API, et cetera, right? So again, distributed firewall, it's blocking, filtering for malware, filtering for Tor nodes, stuff like that, filtering for countries. I'm combining that with what's called a private service connect. The presentation that was this morning, right, talked about what the ins and outs of were private service connects. So that's a virtual NIC, allowing me to connect either a third-party API, a Google Cloud API, or an API within my organization. So basically I'm keeping my LAN or my secure network in the bottom green box away from my DMZ, which is kind of floating in this case, floating being that I don't have a direct next-gen firewall appliance that has a hard physical link into it, as well as it's scalable. So, and then it's hitting the secure web proxy. Why is the secure web proxy sitting out here? Because I can scale this out and have maybe a dev test prod type different environments. and they can all connect back to a centralized web proxy where I just have to configure this once. Again, so floating DMZ. And then I can combine that with Cloud NAT to get an outside IP address and go the other. Our third use case that it addresses is coming in. And so we talked about this in the first presentation, but you can use a load balancer combined with Private Service Connect. And you also can use the next gen firewall there to secure workloads coming in. So think about our first presentation about exposing workloads to the internet. And we really just talked about kind of layer 3 and down and how the traffic would be exposed. We didn't talk about securing the traffic from malware, countries, or basically attackers. So we can use this same type architecture and throw in a cloud NGFW to secure those workloads as well. And then we have this secure ingress solution and secure egress solution, a floating DMZ, and it again can be segregated into our teams for separation of duties. So we can have our security team separate from our platform team, separate from our developers, each with their own type areas, as well as different code segregation there. So technical benefits, right? When I'm talking to my technical teams and I want to sell this solution, or I'm talking to companies and their technical teams and I want to sell this solution, right? These are our technical benefits. So with this, all the products are highly available. They're distributed across Google data centers. So you're protected against, zonal and regional outages. They can scale up. It doesn't matter how much traffic is going through them. They can auto scale. So as well as everything that you saw was infrastructure as code, right? It can also all be basically what we call policy as code in the security world. Everything can be implemented in code and iteratively made better, as well as promoted to higher environments, which is reduces downtime. So the I can never say that word, hierarchical deployment is used so that you can define policies at the org level and implement or not implement these policies throughout your organization. What hierarchical policy, firewall policy also allows is, and what's really cool about Google is I can take a local firewall deployment, local VPC firewall, and I can choose to evaluate it before or after the hierarchical firewall, allowing me for extreme control. There is no licensing. This is a big deal, but a small bullet point. When I want to bring that legacy data center architecture with appliances, I have to go through purchase order, approval, ship, all that stuff to get licenses, stuff like that. It takes time, it takes money. I've got to involve other teams. With this solution, there's no licensing. You're only OpEx, right, with Google. You're paying for what you use, and that's it. Let's see here. There's also low operational and configuration overhead. If you wanted to implement this, we could implement it today, even in code. There's modules out there. It's quick, it's easy, and we can iteratively make it better for our organization. As well with the secure web proxy, we're getting that much needed observability that security teams ask for. So we can see exactly who's who in the zoo, right? And who are they talking to? I think that's, if you've heard that term before. So I know that this service talked to exactly this URL on the internet, or this service got blocked trying to go to this country on the internet. That's an awesome feature in itself, getting that level of visibility with no appliance, no license, and easy configuration. As well as the granularity of these policies, just what we've been saying over and over, right? I can literally give you a URL to an that lives in a specific country and allow or deny it, as well as understand what you did when you tried to contact it. So those are the technical benefits. And then obviously you've got your business teams. And so if you're addressing the business teams with this solution, Obviously, this allows you to go fast, right? So fast time to market. I can deploy a secure service in Google Cloud, in minutes or days versus months. Where, if you were to try to deploy this and say, go to a new data center or another cloud or even Google Cloud and use legacy architectures with next gen firewall appliances, it would take you, it's not easy and it's laborious, right? So you're cutting down on your time. It's a cloud native solution, obviously. So, but the benefit there is it works well with other cloud native services. You can throw in Apogee, you can throw in load balancers, and it plays nicely with all of these items, GKE gateway, as well as, it's all in code. So therefore I can take development teams and iteratively develop. It doesn't have to be a one-person job. I'm logged into a firewall appliance configuring it. I can't have another person log in to a firewall configuring the same rule. But with code, your Git takes care of that, right? GitOps process, and it becomes an easy collaboration. This meets compliance. And then also these features, next-gen firewall and secure web proxy, are complementary of each other. So you're getting better than something that you would off the shelf. As well as observability, right? So we can make informed decisions from a business standpoint. My developers are trying to hit a service here. Can I deploy it somewhere else? Can I secure it better with my observability? And I can make informed decisions about where to go with my security or where to go with my business. So we address all of those with this solution.